Hello and welcome to Math Matters. I'm Ms. Granados and today we're going to be learning about computing fractions. In today's lesson, we'll be solving practical problems involving fractions and mixed numbers, and then sharing our thinking about how we solved it. We'll look at the connections and differences between two different strategies. As you review this content, you'll be using the portrait of a graduate skill of communicator, and also that of creative and critical thinker. You're communicating your thinking when you write down your strategies, or when you share your strategies orally with someone near you. Anytime you think about a problem and come up with solutions, you're being a creative and critical thinker. You'll be doing that a lot today. Just like in previous lessons, you'll need some paper and something to write with. So go ahead and quickly gather your materials and come right back. Today's number sense routine is a splat. I'll walk you through it. What number is represented in this model? Well, let's count the blue circles first. Since the whole circle is shaded in, I'm going to count by whole numbers. 1, 2, 3, 4. Now the other circles are split into 3 equal parts, and one of those parts is shaded in green, so I can count those by 1/3. 1/3, 2/3, 3/3, and that's the same as 1 whole. So all 3 green parts make up 3/3 or 1 whole. When I add the 4 wholes to the 3/3, I get 5. Okay. Splat. What's the total under the splat? What do we know? How many can we still see? Well, let's count the whole numbers first and then the fraction. 1, 2, 2 and 1/3. We can still see 2 and 1/3, and we know there are 5 total. So how many are under the splat? Use your communicator skills to explain or justify your answer, either by explaining it to someone near you or by writing it down. If you know how many are under the splat, can you think of a different way to think of the splat? You may have thought of what we started with, 4 whole circles and 3/3. Then you might have thought about taking away the circles that we can still see. We can then count how much is left. 1, 2, 2 and 1/3, 2 and 2/3. So 2 and 2/3 is what might be under the splat. How could we write a number sentence for this strategy? Well, we started with 5 and took away the parts we could see, 2 and 1/3, so the equation could be 5 minus 2 and 1/3 equals 2 and 2/3. What's another strategy? Maybe you started with what we could see, 2 and 1/3, and then counted up until you got to the total of 5 whole circles. Once we got to 5, we'd need to figure out how many we added. So to figure out how many more we added, we can start counting the whole circles first and then add the fractional parts. 1, 2, 2 1/3, 2 2/3. So we added 2 2/3 more to get to 5. What equation represents that strategy? 2 1/3 plus 2 2/3 equals 5. Let's see if we're correct. Let's look under the splat to see the total. 1, 2, 2 1/3, 2 2/3. Yay, we were correct. All right, let's move on to our story problem. Mo needs some cups of flour to bake a cake. He has some cups of flour. What are you picturing in your mind as we read this story? What kind of cake do you think he's baking? What ingredients might he need? I'm going to read the problem again. Mo needs 4 1/2 cups of flour to bake a cake. He has some cups of flour. What changed in the problem? And what did we learn from this new information? Yeah, it tells us 4 1/2 cups of flour. That's the amount of flour Mo needs to bake the cake. He needs 4 1/2 cups of flour. Can you imagine that much flour? That must be a big cake. So he needs 4 full cups and then another half cup. Okay, I can imagine that much flour. How much flour do you think he has? Mo needs 4 1/2 cups of flour to bake a cake. He has 1 3/4 cups of flour. What changed in the problem? And what did we learn from this new information? Well, we now know how much flour Mo has. He has 1 3/4 cups of flour. Okay, can you imagine how much flour Mo has? 1 full cup and then 3/4 of another cup. So we know that Mo has 1 3/4 cups of flour and he needs 4 1/2 cups of flour. Does Mo have enough flour to bake his cake? How do you know? What question might we ask about this situation? Let's reread this story problem. Mo needs 4 1/2 cups of flour to bake a cake. He has 1 3/4 cups of flour. What question might we answer? How much more flour does Mo need? Well, let's estimate. We can round one of these numbers to the nearest whole number. Let's say Mo has 2 cups instead of 1 3/4, since we know that 3/4 is close to 1 whole. If he had 2 cups of flour, then I know that another 2 1/2 cups would give him 4 1/2 cups, which is what he needs. So my estimate is about 2 1/2 cups. Now it's your turn to work on the problem. How can you use pictures, numbers, and/or words to answer this question? How much more flour does Mo need to bake this cake? You'll have about 3 minutes to work on this problem. So I'm going to show you two different students' strategies. Let's hear how Liz solved this problem. First, she thought of how much flour Mo already has, 1 3/4 cup. She decided to represent it with the fraction tiles she remembered using in class, with 1 whole and 3 of the 4th pieces. Then she thought, wow, I'm only 1 more 4th piece away from the next whole. So let me add that to what Mo has. Liz knows that 3/4 plus 1/4 equals 1. So that means that 1 3/4 plus 1/4 has to equal 2. Well, she kept in mind the 2 whole cups that she just made and then added 2 1/2 more, knowing that 2 plus 2 equals 4 and another half makes 4 1/2. So what's her answer? 4 1/2? Actually, Liz knew that she started with 1 3/4 cups and added more until she got to the total needed, 4 1/2 cups. So her answer was not 4 1/2. She went back to what she added. First, she added 1/4 to make 2. Then she remembered that she added 2 1/2. She knows that 1/2 is the same as 2/4. So 2 1/2 plus 1/4 is the same as 2 2/4 plus 1/4, which is 2 3/4. Now let's look at Adam's strategy. He decided to start with the total cups of flour that Mo needs, 4 1/2 cups. Then he thought about taking away the amount that Mo already had, 1 3/4. He decomposed the mixed number 1 3/4 into 1 whole and 3/4. Adam knew he could take 1 whole away easily. He wasn't sure what to do about taking away the 3/4 because he didn't see any fourths. Can you think of what he should do next? Well, he remembered that 4/4 is the same as 1 whole. So he decided to change the 1 whole into 4/4. Now that Adam has 4/4, he can take away 3 of those fourths. Then Adam has to count how much he has left. He can easily see the 2 1/2, so he adds the 1/4 to the 2 1/2. In order to find the total, he exchanges 1/2 for 2/4 and then adds up all the fourths. Adam could write an equation or two for this strategy. The first is 4 1/2, or the total cup of flour Mo needs, minus the amount Mo had, 1 3/4, which we can see here is the same as 2 3/4. The other way is for Adam to write two equations to show how he decomposed 1 3/4. Again, he starts with the total cups of flour he needs, 4 1/2. But then he decomposes the 1 3/4 into whole number and fraction. So he subtracts the whole number 1 first and gets 3 1/2. Then he starts with 3 1/2 and takes away 3/4 to get 2 3/4. Let's spend a little bit of time comparing Liz's strategy with Adam's strategy. What's the same about how both students solve this problem? And what might be some differences? Let's start with some of the similarities or things that are the same about the two strategies. First, they both came up with the same answer of 2 3/4. Another similarity that I noticed is that they both broke up a whole or the 1/2 into fourths. They also both used the fraction tiles to represent their thinking. Now, what about the differences? Well, they both started at different places. Liz added and Adam subtracted. Liz started with how much flour Mo already had and added on to that amount until she got to the amount he needed, whereas Adam started with the total amount Mo needed and took away the amount Mo already had. Another difference is that Adam decomposed 1 3/4 and subtracted each part separately. First, he subtracted 1 whole from the total of 4 1/2, and then he subtracted 3/4. Liz composed the amount of flour Mo still needed by adding the two amounts, 2 1/2 plus 1/4, to the amount Mo started with, 1 3/4. Let's review. Today we spent some time looking at and solving a splat and a fraction story problem. Did your strategy match either Liz's strategy or Adam's? Maybe you had a different way to think about solving the problem. The important thing is for you to understand what's happening in the story problems that you solve, and to solve them in the way that makes most sense to you and that you can explain. It doesn't matter if you use pictures, numbers, actual manipulatives to solve the problems, as long as it's a strategy that you understand and can communicate your thinking. Here's the learning target for today. Some of the skills you may have used today include those for a communicator and for a creative and critical thinker. In your notebook or on some paper, write down something you learned today and something you may still be wondering about. In today's episode of Math Matters, we learned about solving story problems that involved adding and subtracting fractions. I'm Miss Granados. I hope you have a great day and keep on counting.